Hey, let's talk about vectors. This is the start of chapter 3 in your AP Physics book. So, vectors are used to describe quantities like velocity when we need magnitude and direction. If you have something called speed, for example, that's just a magnitude. Speed, say, of a car on a highway, that doesn't matter what direction it's going. However, when we talk about velocity, that means the speed, which is the magnitude, and the direction that it's going. So anytime we change either the speed, that rate, or the direction, we have a new velocity. We have a change in velocity. Vector math is the important thing here in this little lesson. So if we start here at this 0 dot, for example, and then we travel to the 1, and then we travel to the 2, and then to the 3, and then to the 4, how far did we go is one question. And how much different is the starting point from the ending point? And that's an idea called net displacement. And we're also going to talk about the components, but not quite as much. That's a lot of trigonometry that you've already probably had. So let us continue on to, let's go right here, back one. All right, so here it is, magnitude of a vector. That will give you some sort of number answer. And sometimes we can refer to the magnitude of a vector as simply a non-vector quantity, like we're talking about velocity versus speed. This is the most common example, of course. Velocity versus speed. Speed is a scalar, meaning the direction is not important. Velocity is a vector quantity, meaning I need magnitude and direction. Vectors are named with any letter and a small arrow over the top. This looks a lot like the notation from geometry class for a ray, which is sort of the half arrow over the top. You can abbreviate the vector names with this half arrow, or you can draw the entire arrow over the top. Either way, if you're talking about a vector, it needs some sort of arrow indication over the top. Now, subtracting vectors. Adding vectors is where we need to start. So adding is always the idea of head to tail. So if we're starting with vector A and we'd like to add vector B, I'm going to try and use a little bit different ones from the diagram. Let's go, B is a short one and it's sort of going up and to the left. So here's my B vector. If we're adding them, it matters what order you go in. Do you remember back in algebra maybe, and we learned that A plus B is the same as B plus A, and that was the commutative property? Well, it is not true when you have vectors. You get actually different answers, incorrect ones usually, if you go out of order. So if you have A plus B, then you must begin with the A, and wherever it starts, that's sort of your starting point. Let's call that. We leave A alone. Start. Now, you trace the A until you get to the arrow point, and the head is what I'm talking about when I'm talking about the arrow, or the arrow is the head. So then you have to pick up this B and place it with, oh, I'm so sorry, there we go, and place it with its tail on the head of the last one. So the thing that you're adding, the second thing in the list, when you're adding this stuff up, that's the one that's going to move over and be set with the head of the first one to the tail of the next one. And so in this case, the result is a vector that starts at the start of A and ends at the end of B. So this is the correct answer from whatever these x and y coordinates are for vector A plus vector B. Now, that might seem pretty good. Do you want to see B plus A? Okay, we'll do that. B plus A. If this is vector B, and I'd like to add vector A, which looks like this, then I keep B where it is, and you can kind of think of coordinate axes starting at the start of B. So now I have to pick up the A and place it from the head of B. I continue with whatever A was. I'm not changing direction, I'm just picking it up and placing it so that the last thing that I draw is the arrow of the last thing in the list as you add first, second, third, fourth, etc. So B plus A would look like this diagram, and I'll use my colors because I can. Start at the start of B and end at the end of A. Okay, now let's talk about subtraction. If you're subtracting vectors, you need to put in your head the algebra 2, or maybe it's earlier, the concept of adding the negative. So subtraction was called subtraction for a while, and then we started saying, oh, you can add the inverse or add the negative. So we need to hold that idea in our head as we talk about subtracting something from something else. So if it says subtract B from A, that means A is our starting anchor vector. So just like it says, draw your starting anchor vector. There we go. A, so here's my start point. Here's my head of A. So now the next thing I'm going to draw will be some sort of vector B, and it's going to have its starting point right there. But here's the deal. If you want to subtract or take away B from A, you actually can't subtract vectors. You have to add them only. But if we're subtracting, then we need to do something with this direction idea. So subtracting is actually adding the opposite. And what is the opposite? Well, opposite in this case is the direction. So that means instead of B starting here and drawing its arrow like this, I flip it around. I reflect it across itself. So now I start here and I put the arrow up here. So now this is actually the negative B vector. And that's the thing that I add to the A. So there it is right here. Next step. Place the tail of negative B at the tip of A. So A is just where I left it. I started here and ended here. The next vector is going to start at this tip, and it is in the opposite direction from my original B because I can't subtract vectors. I can only add the opposite. So that means B is actually going to go this way. And the last thing I draw is the arrow end of the last thing in my list. So the result is the vector that starts at the start and ends at the end, which is this purple vector. So they've drawn it here for you like this. This is vector A minus vector B. Now here's an application of subtracting vectors. If we know the initial and the final velocities that are represented by these arrows, then we want to find, say, the change in this velocity. Well, the change in anything, just like when we calculated slope, we would always say it's the final minus the initial. So here we have to subtract the vector. We have to keep the v final where it is, and then we have to add the negative version of the v initial. So I keep the v final, and now I look at this v initial, and all I have to do is basically put the arrow on the other end. So that's what they've done here. The arrow is now up at this top left. So I've got v final minus or plus negative v initial. Well, what does that leave you with? It leaves you with the change in velocity vector, change represented by the capital Greek delta right there. So that means that when I go back to my original drawing of v initial and v final, I can use this vector with this length and going in this direction to represent that change. So between vector 1 and between the initial vector and the final vector, I have this much change, and so now I represent that right here. And if you have a changing velocity, what do we call that? Acceleration. So this is the vector version of that lesson. So now, which of these, A, B, C, or D, represents the sum of vector P plus vector Q? Well, until you get good at this, I want you to think about picking up the second one, in this case vector Q, and placing it with its tail at the tip of the first one. So the head here continues on with the tail over there. So what are you left with? Well, you're left with a vector that starts at the original starting point of P and ends at the final ending point of Q. So that means it would have to be vector A. Great job. How about another one? How about P minus Q? Well, I always leave the first one where it is, so I've got P starting here, and I got P ending up there. Now, to subtract a vector, I must add the opposite. In this case, the opposite means it goes in the other direction. Same magnitude, different direction. So, keeping the P where it is, I now start writing my Q vector with its tail at the head of P and going in the opposite direction. So it'll be going up this way. And what is that resulting vector? Well, the resulting vector is the one that I draw when I start at the start of P and I end at the end of Q. Ooh, I clicked the slide too quick. There it is. The one that goes straight up. B. Okay, one more. How about Q minus P? Keep Q where it is. Switch the direction of P. Start writing the next vector wherever you stopped with the first vector. And it'll go down this way, leaving you with start at the start, go to end at the end, and that vector would be C. And the last part, vectors and vector components. Anytime you have a vector going off at an angle, we can always figure out, based on the x and y axes, what the components are. And this is just straight back to all of the right triangles that you ever figured out. So if we want the vector, oh, they used B, I'll use A. If we know that this is the vector and it has some sort of angle, that means it's going in the x direction and it's going in the y direction. How much x and how much y? Well, this is how we do it. Once you can think of the original vector as somebody's hypotenuse, sorry, don't have enough room for that, Then you can think about this as a right triangle, and the distance along the x-axis will be the AX, and the distance along the y-axis, or parallel to the y-axis, would be the AY component. So you can, let's say this is 5, and I know it's a right triangle, so that's sort of a dead giveaway that this side was 4 and this side was 3. What if it's not so easy? What if this is 5.9? Now what? Well, you'd have to do some trigonometry. Either they'll give you the length of the hypotenuse and the direction, which is very common for vectors. Say you're going 200 kilometers per hour at 12 degrees east of north. In this case, this looks a lot more like 30 degrees, 60 degrees east of north, or 30 north of east. And so whatever this angle measurement is, that's what you're going to use with sine, cosine, and tangent. To get the y direction, it's going to be sine of your angle will be the AY over the hypotenuse A. Cosine of that angle will give you your AX component, your x direction component, divided by the length, or the magnitude rather, of the A vector. And that should be some review. Great. Go practice. Thanks for tuning in.